Hi, my name is Nicholas Adams, and this is my final project for Calc 3 with Professor Igor at MassBay Community College about the 4 different coordinate systems. So the first of the 4 are Cartesian coordinate systems, and this is the most basic coordinate system according to most people. There can either be 2 or 3-dimensional graphs. The often case is the y-axis facing upwards and the x-axis going left and right, and this would be a 2-dimensional graph, and it would be written as x comma y. For the 3-dimensional graphs, you would add the z-axis just like that, and then you'd have x, y, z written as x comma y comma z. The next one that we're going to be talking about today is polar coordinates, and this is 2-dimensional objects that revolve around an axis. So if this was the x-axis right here, it could look something like that. And polar coordinates can only be in 2D, and it's written as r comma theta, with r being the radius and theta being the degree of the angle. Next up, we have cylindrical coordinates. This one is the same as polar coordinates, but it's 3-dimensional. And because of that, we add z, the same axis that we add for 3-dimensional graphs up here. For spherical coordinate systems, that is often used for geometry that radiates from a single point, such as the light that gets emitted from an LED. And that, we use 3 different variables down here. The first one that we use is rho, the second is theta for the angle, and the third is phi. And the second 2 are both angles, and the first one is the distance from the origin to the center of it. And now we're going to be doing some examples of why people would actually use the different coordinate systems. And the main reason is because it makes equations easier. The first one that we're going to do is z equals x squared plus y squared minus 4. And this is written as a Cartesian point, and we're going to be moving it into the cylindrical coordinate system. So as you can see right here, it's written in x, y, and z. And we have x, y, and z right here, plus numbers. And the numbers are just where they are on the graph. And for this one, there's r, theta, and z. So we have to get this equation clear of x and y. And to do that, we're going to be using the equation r squared equals x squared plus y squared. And we have an x squared and a y squared right here. So we're going to cross those off and then have the new equation be z equals r squared minus 4. And here we have all of the appropriate variables. We can have r, theta, and z, and we just have z and r, because there's no need for theta. Now to see if this works, we're going to go over to Desmos, which is an online graphing tool. We can see the blue object right here, and if we look up in the corner, we have z equals x squared plus y squared minus 4. So this is the equation right here on the graph. And as you can see, it's a 3-dimensional cone-like object. And then if we turn on the z equals r squared minus 4, so the equation that we came up with using that equation, as you can see, it's the same exact sphere. And in fact, if we turn off the blue, it will stay looking the same. And this is just one of many examples that I cover in my full essay. So if you're interested in looking more, visit the top comment down below. Thanks for watching.